Great, well thank you. I'm currently a postdoc with a background in behavioral ecology as well as resource and environmental management. And right now I'm working in a geocomputing labs because of the type of methodologies that I'm using in the Caribou system. And I'm working with this fine array of collaborators that you see on the screen. So together our ultimate goal is to eventually move towards scenario planning of caribou. But by first gaining a detailed understanding of the processes that are driving caribou habitat selection, as well as the responses to industry and their landscape. So to this end, we're looking at drivers of habitat selection, the first phase of our research. What we've done is we've developed a spatially explicit, agent-based model of caribou to simulate and to recreate the movement behavioral strategies of caribou. And the reason why we're doing this is to explore how, and more importantly, why they select and use their winter habitat. We're focusing in this first iteration of the project on the Little Smoky herd. I'm sure most of you are familiar with it. It is 78 individuals are thought to be remaining, and it's been deemed a local non-sustaining herd. One of the reasons is due in part to anthropogenic activities such as oil and gas and forestry industries that have put a large industrial footprint into the area. And I think recent estimates put around 95% of the Little Smoky range within proximity of a 500-meter buffer to these anthropogenic activities. So this is our prototype herd that we're working on. The methodology I'm using is called agent-based modeling. It is a computational tool that actually finds its origins in artificial intelligence. And that's because it uses entities called individuals or agents that are given autonomous rules. They can basically internalize, they can sense their environment, they have an internal state, they can interact with other agents, and they're given fitness maximizing goals, they make decisions, and they interact with their environment. And it's through this intimate relationship between the agent and its environment that we can then describe and predict differential species by animals and by individuals, and ultimately identify the habitat that's important to the species and the animal in question. In my caribou agent-based model, we have two crucial components. One is the landscape representation, which will be the Little Smoky and is the Little Smoky, as well as the caribou agents that we need to imbue with caribou ecology, caribou biology. So with respect to landscape representation, we created the Little Smoky from the point of view of a caribou by combining a set of raster images at a 45-meter resolution. So we took a land cover map, an industrial features map, as well as a digital elevation model. And what we did was we created a habitat index. And we used these indices and we inputted them into a grid over which our agents eventually move. And each cell in this grid then has three values: a forage availability value, a predation risk score, and elevation. So for example, when a caribou is moving over this grid and encounters that white cell, which originally was muskeg in the land cover map, well, it has a forage availability that's around medium. It's not as good as, let's say, prime habitat of closed conifer forests, but again, it's a lot better than, say, shrub in wintertime. And its predation risk score, it's, again, not as risky as being in water, frozen water, which is known to be risky for caribou in the Little Smoky. But again, it's not as safe, let's say, as closed canopy forests. And it has an elevation of, let's just say, 1,200 meters, which we use to calculate movement costs. So this is what the agent is seeing when it's making its decisions. And what decisions are these? Well, our caribou ABM and the agents within it, they're actually based on actual caribou bioenergetics. So what's motivating them across the landscape is their internal energy reserves. We're using the realistic bioenergetics, realistic movement rates, as well as ungulate foraging theory. So I'm just put up there an example of how an agent might react and respond to its environment. So let's say the agent assesses its internal state and realizes that it needs to forage. But the area that it's located in, it perceives it as being around medium predation risk, not terribly high, not terribly low, but it doesn't want to forage in its present location. So what it's going to do is assess its surrounding location. If the surrounding area is just as risky, it's not going to move there and forage, it's going to try to find a new place. Or it's going to see if it's just as risky, but the food is even better, well, it might actually decide to go there to forage instead because it's going to trade off. It's willing to take on the cost of predation risk if it's hungry enough and the areas of better quality. This is just an illustrative example to show you the kind of behaviors that these agents are engaging and using as they're moving across the Little Smoky landscape that's been simulated. So in order now to evaluate how well the model does, of course, well, we need to see, is it realistic? And to validate whether or not it's realistic, we actually used and extracted multiple patterns from actual GPS telemetry data from Little Smoky, females in Little Smoky in the year 2004 and 2005, wintertime. Again, then this was correlates with the land cover classes we used, which were also time-stamped to 2005. What we decided to use, these patterns were not random. They were they represent trends and behaviors of caribou happening at different spatial scales and different temporal scales, and showcase different behaviors of the caribou. So they were explicitly shown and chosen as a way to validate what our model was telling us. So we compared and contrasted simulated outputs with the outputs we extracted from real caribou. What we found was that the strategies that best explained and best emulated and recreated real movement patterns and behaviors of caribou in Little Smoky was when they had the following three strategies they would use. They would acquire their daily energies. It was important for them to meet their daily energetic needs. But it was also important for them to conserve enough energy for reproduction. But at the same time, they were expending energy trying to minimize their exposure to areas that they perceived to be high risk, whether from predation or from industrial features. So knowing this strategy and allocation of strategies that caribou are using, the simulated one, well, it now actually provides a mechanistic link to understanding caribou spatial distributions that we see in Little Smoky. And it also establishes a baseline of behavioral baseline of caribou responses. And in combination, these two factors now allow us, in understanding these mechanisms, we can now examine how caribou might respond to future changes in their environment, because the principles that we're working on are evolutionary ecological ones, and they're not empirically driven. Again, it's what the caribou itself was motivated in order to survive, to reproduce. Now what we're doing then is currently developing future plausible Little Smoky landscapes for scenario planning. So here we have Little Smoky in 1998, and as we go forward in time, we can see the changes happening on the landscape. So one way to create future landscapes is just to use the historical trend to project into the future, business as usual, with some constraints obviously built in. But we can also play around with this too. We can actually, by talking to our sponsors and our partnerships with our studies and other stakeholders, we can devise different scenarios that are of interest to stakeholders. So for example, let's say future development is going to happen within 500-meter buffer of industrial features. We could model that scenario. We can model different scenarios, for example, storing old seismic lines by doing the plantings. Or we could limit new development happening in terms of restricting, like we heard this morning from Elston, the 2020, the 2030 in the area. What we're then going to do is place our agents on these newly created landscapes to explore how changes in development might affect the caribou habitat use, the functional use of the habitat, as well as caribou fitness. And so we're hoping this to become an ecological forecasting tool or a decision support tool that can hopefully, we can enter into discussions and open dialogue and engage in the future conservation planning of the species. And again, just because we've concentrated on the Little Smoky, it's definitely adaptable to other herds and in other areas. We would have to fix the ungulate foraging ecology to specify arboreal versus terrestrial, but it's definitely doable. And so we're excited about this, but I would like to take your feedback on it as well. Thank you.